Okay, here we are. Thank you. Siemens. All the time I've been in touch with somebody and they ask me, what's your job? I say I work for Siemens and the people just tell me, the one who provides the mobile phone? No. Okay, the furniture, the electronics stuff? No. That's not that Siemens. Siemens, as you see, is composed by different business units. And one of the business units, which is called Digital Industries, is the one I work for. So in particular, the Digital Industries Software division is dedicated to sell the software to build the digital twin. This is the abstract. I will move forward and let me move to the other part of the presentation. So everybody is living the digital transformation here. Is impacting every single industry, every single person, and let's say we are living in this digital transformation. And the scope, the benefits of this digital transformation is to improve the efficiency, reduce the cost, and of course, drive our growth. How are you living this digital transformation? How are we living the digital transformation? It's a journey. Thinking at the beginning of my career, and let's say tentatively to the 80s until 2030, we can think that we are living this transformation, moving from the paper to the 2D, to the 3D, to the DMU, to the simulation, and of course this was supported by hardware and not only software, by hardware as well. So we are living also the evolution of the technical support that is providing us the possibility to continuously evolve and improve. And moving towards the arts, we have seen the augmented reality, the virtual reality, the multidisciplinary simulation and design, which was named Industry 4.0. I can guess that everybody has heard this, the Industry 4.0. And again, the support was the industrial Wi-Fi, the cloud, and so on. But it's not enough. It's not enough because we have to work and to engineer the product and to engineer the production and to engineer the simulation and the performance into a multidisciplinary ecosystem. That, of course, is helped by the artificial intelligence. And that's why we talk about digital twin, extending the digital twin to the executable digital twin, and moving with the cloud and the 5G to the industrial metaverse. Now, a little bit of statistic. How many of you have heard about digital twin? Everybody, of course. How many of you have heard about the extended digital twin? Industrial metaverse? Okay, so I'm happy to see that not all the people are rising the end, because I can share something you've never heard before or you've heard only partially. And let's go to investigate how we move from the high-fidelity digital twin to the hyper-reality digital twin, moving to the industrial metaverse with this criteria. What is the comprehensive digital twin? I'm not describing in words, using words, what is the digital twin, because you should kill me. You know, I know what's the digital twin. I want to share with you what is the digital twin for Siemens. Not because we are inventing something different, but because we are providing solution. We are providing the digital thread components to build the digital twin. For Siemens, digital twin is not only the twin of the product, because we have to take care also about how we produce that product, and so we support the digital twin of the production of the factories, for example. But this is not enough, because we have also to take care about the digital twin of the performance. The life cycle of the product starts from when it was thought, the very first time, to when it's destroyed, it's scrapped, is used. And so that's why we take care about the performance as well. So when we speak about a digital twin, we compare the digital and the real product, the digital and the real production, the digital and the real performance, and we mix together to try to create a loop, a closed loop, taking the data of the performance that is used to improve the new product and also for the maintenance purpose as well. Let me show you a video which is summarizing very shortly the different scope of the digital twin solution supported by Siemens. It's not all inclusive, it's just a flash. There are two sentence words that I really like from this video. One is the holistic approach, because it's true that during this evolution we have to work in an holistic way, thinking completely in a wide dimension. And another word that is very important for everybody is sustainable industry. One of the most frequent requests we receive from our prospect and customer is this: I need solution because they say they don't use the terminology, I want to become sustainable. They say, I must become sustainable, because sustainability today, it's not a wish, it's a must. And that's why the digital twin is helping more and more to become sustainable, because, of course, we can produce these products and production virtually, saving money, reducing errors, reducing the physical prototypes, and improving the time that we have to dedicate to ramp up to the production phase. So that's why it's important, but let's see some testimonials that are really demonstrate with their job using Siemens software, but not only, because we are absolutely open. We know that every type of industry doesn't buy all the software from one single company, and we don't want to force the customer to scrap everything and to use only the Siemens software. We are open to collaborate and, of course, to improve with this integration the results. Let's see an example of reducing the errors, reducing the cost, and, of course, also reducing the physical prototypes. I'm talking about Bugatti. Who knows Bugatti? The big sport cars. Nice, very nice car. Of course, as all the cars has to be certified with the crash test for the security of the people inside the car. And let's see the testimonial of provided by Andrea Pontremoli, which is the managing director of Dallara. This is an example, for example, of a customer which is not using only the Siemens software, but they have been able to help Bugatti. This car was realized in 2005, so quite many years ago. But also at that time, we could leverage on the benefits of the digital twin. Let's see.
Bugatti, quando è venuta da noi la prima volta, Bugatti più o meno, diciamo, una macchina media stava intorno ai 2 milioni e devono passare i crash test. E non è facile per una macchina che ha un motore 16 cilindri, 4 turbo, pesantissimo, 2 tonnellate, passare i crash test. E devi sbatterla contro un muro e salvare il manichino che c'è dentro. Allora, sbattono una macchina contro il muro, non passa il crash test, ne sbattono un altro, non passa il crash test, insomma, ne hanno sfasciate 16 e non avevano passato il crash test. Intanto era passato un anno, perché 2 anni fa quelle 16 macchine. Quindi è passato un anno, hanno sfasciato 16 macchine, 16 per 2, 32, sono 32 milioni, quindi speso 32 milioni, è perso un anno e non passi il crash test. Vengono in Dallara, dice, ascolta, ci studi tu? Va bene, noi abbiamo i nostri sistemi di simulazione, quindi abbiamo passato migliaia di macchine contro il muro, in virtuale, e poi abbiamo fatto una macchina e ha passato il crash test. Quanto gli dovevo far pagare secondo voi quel servizio? 32 milioni è poco, perché se avessi pagato anche un anno.
It's funny, but it's true. Can you imagine the panic from Bugatti's people when they couldn't pass the crash test? They couldn't produce the car without this type of certification. And so this is a real example where they save money, they save time, and of course they reduce physical prototype, which is a waste of material, a waste of energy. So In this way, they have been more sustainable. But this is not the only example. There are some examples, you know, where it's not a matter of timing. It's a matter of doing right the first time, because there's no possibility of error. You must do it right the first time. I'm talking about the Curiosity rover, which was realized and landed on Mars in 2012. We are moving through the years. And of course, also this time, we provided to NASA JPL solution to build and simulate the Curiosity rover. Zero margin of error. This is the key word.
But success of the JPL Curiosity rover Mars Science Laboratory required a level of complex engineering and planning beyond any other mission to date. The team had to design a vehicle to house the world's most advanced scientific laboratory in a space rover, plan how to safely transport a 1 metric ton payload, and plan how to safely land it on Mars, all in a virtual environment. And there was zero margin of error. Siemens PLM software gave the JPL engineering team confidence that their decisions through design, build, test, and validation would result in success. The rover is made up of tens of thousands of parts that needed to work together to get through launch and beyond. The 2-year scientific mission required a redundancy of systems, which doubled the density of the systems on the rover. But the trick was that the size and volume of the payload could not increase. JPL engineers used Siemens PLM software to help design and test the parts before assembling the system. Extreme temperatures posed another major mission-critical challenge. Thermal analysis ensured the team that the Curiosity rover, all of the sophisticated instruments, and the spacecraft that housed it all could endure the extreme temperatures. Curiosity's total mass is 15 times larger than the science instrument payloads of 2 previous Mars rovers. Innovative maneuvers and technology to land a heavier spacecraft with greater precision were also developed and proven using Siemens software. And Curiosity made a perfect landing in August of 2012. PLM software technology from Siemens was also used by JPL engineers to design and simulate the 10 highly sophisticated science instruments aboard Curiosity. These are now successfully being used to send lab results of rock samples back to Earth to analyze and determine whether conditions were ever favorable for microbial life on Mars. During the rover's 2-year mission, experiments like these will help us learn more than ever before about the red planet. From the smallest mission detail to the most complex engineering feat, Curiosity proves that Siemens PLM software is mission critical for a trip to Mars.
So this time, we cannot say we eliminate, we reduce error. We have to eliminate completely the errors. And of course, realizing many virtual prototypes and simulating them with this multidisciplinary simulation. The last example, not because we have only 3, but of course in the interest of time, is this one, which is related to VinFast. VinFast is based in Vietnam. is an automotive company which is producing electric scooter and car. And their objective was to create a production plant from scratch in less than 2 years. From scratch, a production plant. So the intent of this plan is also to be scalable, because they want to be ready to improve the production quantity and line of product, and at the same time they want, of course, to implement the lean manufacturing plan operation. And we supported this company with our product, with our software, in order for them to be able to create the digital twin of the factory and simulate it before producing physically. But this is not enough. We have been talking about the digital twin so far, and this is also well known. Maybe you didn't have the perception of the huge amount of application that is available. But today we are also talking about the extended digital twin, or is also called the executable digital twin. So what's about the executable digital twin? Is realized by simulation, system simulation, or test-based model, which are packaged and are deployed inside the physical asset. So being inside the physical asset, this extended, or it's also called executable digital twin, is able to transform the IoT data towards the simulation, providing some type of information to the engineering. So it's providing information related to the behavior of the product, and in this way we use it to control and to optimize, but it's also used for the maintenance, in order to predict the maintenance instead of realize scheduled maintenance. This possibility to predict the maintenance is absolutely important, because it's saving time, and is also able to improve the time, the usage time of the product itself. One typical example that I provide to explain when a possible use case, when the executable digital twin is important, is where we cannot set up the physical testing sensors, because maybe the temperature is too high, and so we have to take some other different data, putting together with this package simulation object, and analyzing the data, we are able to extract some other behavior that was impossible to measure. This is only one of the examples. But this is not enough, because, of course, as everybody, we have to leverage on the artificial intelligence, which is used together to help ourselves, to help our life, which is the role of the artificial intelligence. The artificial intelligence is a key component in every single piece of our software. There is not one piece when it's not available and it's not useful. And when I talk about the artificial intelligence, I used to say, of course, that we are only at the beginning. The best is yet to come. We are continuously working and improving, extending the AI with the help of the AI, which seems to expand a lot our possibilities and capabilities with a different scope. For example, we use the AI to analyze, setting a solution that is able to predict and guide the user in their daily job, to navigate the huge amount of data. Yesterday, we have heard about the challenge to have a lot of data to be stored, but it's not enough. It's also a challenge that this data has to be analyzed. And the AI, we can leverage on some possibility to filter this huge amount of data and go directly to the data which are really matter. Then we use the AI to optimize the product, to balance the trade-off. But of course, last, not the less important, we use the AI to generate models, to generate multi-domain tasks, and to generate code. I have decided to share only one example in the interest of time. We have many, but this one was the one that was more important for me. Using our software, our simulation software, we asked to design an architectural model for a car, and this car has been, the architectural model has been designed, and I can interact with the software, deciding if I have to choose the four-wheel or the two front, rear or rear driving system. And interacting with the software, I can also ask to simulate the performance and to compare the four-wheel drives with the two. I'm running it again because it's quite fast, but I want to underline that the software with the high capabilities is connected to the user, to the end user, and asking questions and providing the possibility to choose from different options and taking the data, the source of data that is the master, the starting point, is able to design a new architectural model and to predict and to optimize comparing with the different solutions that we can deploy. Why it's important? Because it's saving a lot of time. Of course, these are all things that can be realized by people, is where they come from, but leveraging on the artificial intelligence, we can have more possibility and we can dedicate our time to investigate and to be inspired by new solutions. And let's go with our journey. We are moving to the industrial metaverse. As for the artificial intelligence, we are only at the beginning. But with the industrial metaverse, what we can take advantage is mixing together the digital twin capabilities and the simulation with some hardware capabilities to be able to visualize the real behavior and to have a visualization of the object like it's real. And you may think, hey, the virtual reality is something that has been invented many years ago. It's true. But years ago, we didn't have the availability of the technology that was able to render a huge amount of data, and together with the rendering of the data, rendering the simulation result, multidisciplinary simulation, of course. So the metaverse is supporting the industrial market to see, to try, to ask. What do I mean? To see. Leveraging on the combination of two capabilities. The capabilities which is able to manage a huge amount of data as a bill of material into the product lifecycle solution. With the visualization RTX that is provided by NVIDIA, for example, by this collaboration, we are able to render real-time some photorealistic visualization. Let me show you an example. It doesn't need to be underlined that there are a lot of data to be managed. And this is not, of course, a picture, this is not a video. This is a photorealistic render that is provided with the collaboration of NVIDIA. And we are not talking about the visualization of the real rendering. As you see, we are mixing together the capabilities to visualize the object, the data, the product, and to simulate it as well. Then we can leverage on the metaverse to try. And having another example, let's assume that we want to visualize this camper. It's quite common. And it's of course important to be able to analyze the refrigerator system or the heating system, the flow of the air, in order to provide a comfortable environment in any type of condition or weather condition. We can simulate, as you see, in a different way, and we have all the capabilities and all the possibility to have a look also at the different parts of the environment, at different sides of the environment, analyzing the heat of the temperature in the different places, or let's say the electromagnetic behavior that is the consequence of having the cable, the electrical cable, moving around, let's say, available, of course, mandatory available into this environment. And the last example that we call it Ask It, it's because we can leverage on the metaverse to mix the behavior of what we have realized and what we have created in a digital way, in a digital format, with the behavior, the real performance. So we can, for example, visualize the behavior of this mixer. This is fryer is producing batteries. And together with the visualization, we can take the data, we can analyze the performance, which is useful for the maintenance, but is also useful to analyze the behavior real time. And if in any case we face an error, together with the AI chat, we can ask a suggestion how to solve the issue that we have found at that time, real time, in the behavior of the product, of the component that we are analyzing. I want to conclude this quick overview with another example, which is the industrial metaverse at Siemens Electronics factory in Erlangen. I smile because I used to say something that I want to share with you. And The question I used to raise is this: do you know which is the best example of a promising software, or if you really trust on a software, which is the best example? And my answer is the best example is when we use the software. So if we Siemens sell some software to realize the digital twin, and we don't want only to sell to somebody else, we use it internally. It is the best demonstration that we real trust, because also using, we want to continuously improve, we want the best for our software. And so this is the demonstration, the first, the customer zero, let me call it this way, of the metaverse, is exactly Siemens. So the industrial metaverse was for the first time implemented in our own factory in Erlangen. I'm moving to the end of this journey with a comment. We strongly believe that this journey is not at the end, is not the beginning, of course, maybe it's in the middle, but what's important is that this is not a revolution. This is an evolution, a continuous evolution. It's not disrupting, as not to be implemented all at once, but I love to think that we are able to inspire the customers that we are supporting with our solution. And I hope that I've been able to inspire you, even if your type of job is different, but you are really the key people who is able to support this evolution, both our evolution as a software, but also the evolution of our customer. Being said that, we have plenty of time for questions, if you have any. I want to thank you, and I just, as a joke, I asked to ChatGPT if it was possible to create my digital twin sister, providing this picture, and this is what has been realized. I believe it's the optimistic digital twin, but it's been funny. A real thanks to everybody for listening so carefully, and of course I'm open to any question.